At the end of the day, you're going to design a VLSI chip which will contain several modules, right? And I told you, let us say this is module 1, this is module 2, this is module 3, module 4, and each of these modules can be a combinational circuit or a sequential circuit, or can be anything, a circuit from digital electronic part. But what we are going to focus is how we are implementing this module using transistors, nothing else, using mere transistors. How we are going to implement this module, that is what our course talks about, the VLSI design. I hope now you got an idea, right? To design this VLSI chip, we have several modules. How we are going to implement those modules using a very basic electronic circuit called as transistors, and how many transistors you are going to need. That is also playing a crucial role, and we have to take care of three important factors, guys. One is the area occupied by the transistors, because if I use more number of transistors, module 1 will occupy more area, right, rather than module 2, module 3 and module 4. So that should not be the case. So area occupied should be less, and the power consumption, that is also a very important factor, because all your mobile devices, they need only some low power supply, right? They need low power supply, because the power consumption should be low, then only we can use that device continuously, right? So the power has to be reduced, and also the speed, that has to be increased. So less area, low power, and high speed, these three are the important factors or characteristics for any VLSI circuit. Okay, so we understood that to design a module in a VLSI chip, we need transistors, right? To implement that particular logic, we need some transistors. That is what I mean by circuit design. Okay, so let us now try to understand the basics of some transistors we are going to use. I'm not going to teach all the transistors from the scratch, because that should have been done using the courses called electron devices or MOSFET crash course or digital electronics. There are a lot of courses available for that. In this course, we are focusing on VLSI design. That is, I told you, we are going to design these modules, the basic combinational and sequential modules, using transistors. So that is what we are going to do in this course. So I'm not going to explain transistor from the scratch. I'll give you a basic idea or a quick review. You will be able to catch it, right? So the transistors are nothing but the three terminal devices which we will be using for implementing our logic, right? And the transistors can be classified into different types. The two major category will include BJT, bipolar junction transistors, and field effect transistors. In this course, or not in this course, to design any VLSI circuit nowadays, we are using field effect transistors only, right? So we are going to use field effect transistors only. Okay, and that technology is actually called as CMOS technology. So understand that VLSI circuits are designed using CMOS technology. Okay, so what is CMOS technology? I will explain, don't worry. Now we will understand two basic FET operation. So FET can be divided into two types. One is nothing but depletion type FET and enhancement type FET. Enhancement type FET, and both depletion type and enhancement type can be divided into N type, P type, N type, P type. Okay, to design any VLSI circuit, or according to CMOS technology, that is what we are going to use for VLSI circuits, right? The CMOS technology uses enhancement type transistors. Whenever I say CMOS, it is referring only the enhancement type transistor, not the depletion type transistors. I hope you know the operations of these, that is enhancement type FET. You know the operation, I hope. Okay, I'll just give you a quick review and I'll explain further, right? And we have N type enhancement type transistors and P type enhancement type transistors. Okay, and we will call this as actually MOSFET. Okay, the classification should go like this. There is actually something called as field effect transistors, which can be divided into two. One is nothing but JFET, MOSFET, and MESFET. That is again another type called MESFET. We are going to use MOSFETs only, right? So CMOS technology, as the name suggests, CMOS means complementary MOSFET. So we are going to use only MOSFETs, MOSFETs can be classified into two types, depletion type and enhancement type. In that we are going to use only enhancement type. So we are going to use MOSFETs, enhancement type, P type and N type. Okay, what are NMOS and PMOS? These are the crucial words. NMOS means N type enhancement MOSFET. Okay, N type enhancement MOSFET. Okay, what do I mean by PMOS? PMOS means P type enhancement MOSFET. Okay, what do I mean by CMOS? CMOS means including both NMOS and PMOS. That's it, guys. As the name suggests, it is nothing but complementary, right? So complementary MOS transistor means you are including both NMOS as well as PMOS. That's it, that's the logic. Okay, so we are going to use CMOS technology. In that we are going to use two different transistors, nothing but the N type enhancement type transistor, which is called as NMOS, and the P type enhancement type transistors, which are called as PMOS, and including them or combining them will give us CMOS, right? So we are going to use all these idea in order to design the circuits, right? Talking about the basics of this NMOS and PMOS. So when I take an NMOS transistor, it is going to have three terminals. Not only NMOS transistor, all the MOSFETs will have three terminals. One is nothing but the gate, source and the drain. Okay, gate, source, drain. Gate, source and the drain. Apart from which there is one more terminal which is called as a substrate terminal, okay, called SS, and the source and substrate should be at the same potential. That have to be noted down. Okay, carefully, source and substrate should be at the same potential, so that they together become as a single terminal. So eventually you will be having three terminals only, right? Physically we are having four terminals, guys. Always substrate will be connected to either ground or VDD. Okay, so substrate will be connected to either ground or VDD. VDD means power supply, 5 volt. Okay, either 5 volt or ground. Okay, so substrate will never become another terminal. Okay, it is just again a physical terminal which will be either grounded or which will be pulled up, right? Again, one more important technical term here is connecting to ground is something called as pulling down. You are pulling down the voltage, right? And connecting to VDD is called as pulling up. Very, very important in VLSI design. Often I will be using this word like pulling up and pulling down. Okay, not only the substrate, any terminal, if you are connecting it to ground, it means you are actually pulling down the node to 0 volt. If you are connecting any terminal to 5 volt, means you are pulling up the terminal to 5 volt. Okay, so pull down and pull up, very important again. So gate, source and drain are the three important terminals of any MOSFET transistor. If you draw the symbol of a NMOS transistor, it will become like this. Okay, where this is nothing but the gate, this is drain, this is source. Gate, drain and source. And if you look at the physical cross section of the NMOS transistors, here that nothing but the gate is there, and here there is a silicon dioxide layer. Okay, which is acting as an insulator. Okay, that is why this is called as MOS transistor. When I say MOS transistor, it means that metal oxide semiconductor. What is metal oxide here? The silicon dioxide layer. That is nothing but the metal oxide. Okay, and you have the N plus regions. Okay, one is nothing but the drain, another one is nothing but the source. This is the gate terminal. Okay, this is the gate terminal, this is the, let us say, source, and this is nothing but drain. And the substrate is gonna be P substrate. Okay, P type substrate is what we are having here, right? And it is very clear that you have to apply voltage to this gate terminal, right? You have to apply voltage to this gate terminal, and that is called as VGS. Okay, so if you apply positive voltage to this gate terminal, let us say if you are applying positive voltage to the gate terminal, all the negative charges of this P substrate will be attracted, right? Okay, how does P substrate can contain negative charges? They are nothing but the minority carriers. The P substrate means, what do I mean by P substrate? It will have positive charges to the maximum. That is, those are majority carriers. Positive charges are majority carriers, and some minor negative carriers which are nothing but minority carriers. You are applying positive voltage to the gate, so when you are applying positive, only negative charges will be attracted. So the negative charges, which are nothing but the minority carriers, they will be attracted, through which you can form again an N channel here, through which you can form an N channel. That is called channel formation. So VGS must be higher, right? VGS must be greater than a threshold voltage. Okay, so here I'll write it here. The VGS, the input, the gate to source voltage, what you are applying, that will attract the negative charges, and that will form a channel between gate and drain and source, right? So that should be greater than some threshold voltage. Then only the conduction will happen. Then only the conduction will happen. This you have to keep in mind. Okay, this you have to keep in mind, right? So in this NMOS cross section, there is N plus drain and there is N plus source, and there is a gate which is above the silicon dioxide layer. If you apply positive voltage at a very higher amount, negative charges will be attracted, and through which there will be a channel formation here. Through this channel, the conduction will happen from source to drain. Electrons can flow, so that current flows in this direction. Okay, so through this channel electrons can flow, and this current is called as IDS, drain to source current. Okay, drain to source current, IDS current, they will tell. Okay, I hope you're clear. And not only the input voltage, that is again, to make this electrons flow, we have to give a pushing force, right? And that is given by another supply called as VDS supply. That is again another voltage should be connected, VDS. Then only the current flow will happen. Simply connecting VGS will not make any current flow. Okay, the electrons can move, the channel will be formed, but if the electrons really wanted to be pushed, we have to connect another voltage source, which is nothing but the VDS. So to make the electrons move, we are connecting VDS. To make the channel, we are connecting VGS. To make the channel, we are making VGS to be greater than VT. To make the channel, we are making VGS to be greater than VT, right? Okay, done. So this is the NMOS transistor mean. This is the NMOS transistor. This is nothing but the gate, drain and the source. Always source will be grounded. Again, always drain will be connected to higher voltage VDD. Means for an NMOS transistor, drain will be pulled up and source will be pulled down always, right? Then only the current can flow like this from drain to source, IDS current. If you connect drain to 5 volt and gate to source voltage to some VGS which is greater than the threshold voltage, right? I hope you're understanding this, right? So this is again the basics of NMOS transistor, right? So if you want to draw this logically, let us draw it logically. I mean, VGS has to be greater than VT, right? So VGS has to be some positive voltage, which can be taken as logic 1. Okay, logic 1. That means for this drain to this NMOS, if you apply 1 to the gate, there is a current flow from IDS. That's the idea. The transistor is on when you apply 1. So please remember this very, very crucial point. To make NMOS on, we have to make the gate terminal as logic 1. Logic 1 means applying a voltage greater than the threshold. So we have to make the gate terminal as logic 1 in order to turn on the transistor, NMOS transistor, right? Okay, so I hope you understood the basics of NMOS. We'll see a quick glance on PMOS too, and then we will move to designing the circuits. Thanks a lot.